Welcome. Let's take a look at finding the limit as x approaches infinity of e to the negative x times 4x squared minus 3. Now, if we attempt to find this limit, as x goes to infinity, e to the negative x approaches 0. And as x approaches infinity, 4x squared minus 3 approaches infinity. So we have an indeterminate form, but our indeterminate form is of the form 0 times infinity. Recall that to use L'Hopital's rule, we need an indeterminate form that is either 0 over 0 or infinity over infinity. So we'll need to use some algebraic techniques to rewrite the function in this limit so that we achieve either a 0 over 0 indeterminate form or an infinity over infinity indeterminate form. Now, as I look at this function, I see that I have e to the negative x. So an easy thing to do would simply to be move e to the x to the denominator of this function. That is, rewrite the function as the limit as x approaches infinity of 4x squared minus 3 over e to the x. Now, in that form, as x approaches infinity, my numerator approaches infinity and my denominator approaches infinity. So now this limit is indeterminate, but this time that form is infinity over infinity. So now I can apply L'Hopital's rule by finding the limit of the ratio of the derivative of the numerator over the derivative of the denominator. So we're going to write an LH over our equal sign to indicate the application of L'Hopital's rule to find what follows. Now we have the limit as x approaches infinity. The derivative of our numerator is 8x. The derivative of our denominator is e to the x. Now as we consider this limit, as x approaches infinity, 8x also approaches infinity. E to the x also approaches infinity. So we still have an indeterminate form of the form infinity over infinity. Now, because it is infinity over infinity, this new function is also eligible for the application of L'Hopital's rule. So we would continue. We'll write LH over our equal sign to indicate the use of L'Hopital's rule. And we have the limit as x approaches infinity of now our numerator, the derivative is 8, and our denominator, the derivative is e to the x. Now as I consider this limit, as x approaches infinity, my numerator remains at 8. As x approaches infinity, my denominator approaches infinity. So if I divide 8 by increasingly larger and larger and larger numbers, this ratio becomes closer and closer to 0. So my limit here would be 0. Let's take a look at another example. We have the limit as x approaches 0 from above of 1 over x minus 1 over the quantity e to the x minus 1. Now as x approaches 0 from above, 1 over x will approach infinity. Now we're subtracting 1 over e to the x minus 1. As x approaches 0 from above, e to the x will approach e to the 0. E to the 0 is 1, and so this denominator will approach 1 minus 1. Thus, our denominator approaches 0, or we have 1 divided by increasingly smaller and smaller numbers, and thus this second term also approaches infinity. So we have an indeterminate form, and the indeterminate form in this case is infinity minus infinity. So what we need to do is we need to rewrite or create an equivalent function that is either of the form 0 over 0 or infinity over infinity, so that we can apply L'Hopital's rule. So in this case, we're going to create a common denominator. So to do that, we will multiply 1 over x times e to the x minus 1 over e to the x minus 1, and we will multiply 1 over e to the x minus 1 by x over x. So what we end up with is the limit as x approaches 0 from above of e to the x minus 1 from the first term minus x from the second term. And then we have our common denominator of x times e to the x minus 1. Now, as we consider this, as x approaches 0 from above, e to the x approaches e to the 0, or 1. We have 1 minus 1, which is 0, minus, and then as x approaches 0, 0. So we have a 0 in the numerator. As x approaches 0 from above in our denominator, we have, in place of this x, it would approach 0. Also, this e to the x minus 1 would approach 0. So we now have an indeterminate form, but the indeterminate form in this case is now 0 over 0. And we are now in an instance where we could apply L'Hopital's rule. So that equals, and we will write LH over our equal sign, and we end up with the limit as x approaches 0 from above. Now the derivative of the numerator is e to the x, derivative of 1 is 0, minus 1 for the derivative of the x. Now in my denominator, I'm going to have to find its derivative, but to find the derivative of my denominator, I'm going to have to use the product rule. So the derivative of x is 1 times e to the x minus 1, so derivative of the first factor times the second, plus the derivative of the second factor, e to the x, times the first. So let's clean that up a little bit. We get the limit as x approaches 0 from above of e to the x minus 1 over e to the x minus 1 plus x e to the x. Now as we consider this limit, as x approaches 0, we're going to end up with e to the 0, or 1 minus 1, so my numerator will be 0. In my denominator, as x approaches 0, we have e to the 0 minus 1, or 1 minus 1, plus 0. So I have, again, the indeterminate form of 0 over 0. And with this form, because it's 0 over 0, I can apply L'Hopital's rule again. So writing LH over the equal sign to indicate what follows is the result of applying L'Hopital's rule. And we get the limit as x approaches 0 from above. The derivative of our numerator in this case is e to the x. And looking at our denominator, our derivative for the first term is e to the x. The derivative of the minus 1 is 0. Then we'll have plus, and now we need to use the product rule again to find the derivative of x times e to the x. So the derivative of the first factor is 1 times the second factor, e to the x, plus the derivative of e to the x, the second factor, so e to the x, times the first factor, which is x. Now, as x approaches 0 from above, let's see what happens in the numerator. In the numerator, I end up with e to the 0, or simply 1. In my denominator, as x approaches 0, that first e to the x term will approach e to the 0, plus then the middle term will be 1 times e to the 0, plus, and then the third term will be e to the 0 times 0. So we end up in the denominator with 1 plus 1 plus 0, or more simply, 1/2. So our limit in this case is equal to 1/2. I hope you find this helpful.